Remote I/O, or remote input-output, is a method of extending the reach of a control system by placing signal interface hardware closer to the process, rather than running long runs of field wiring all the way back to a central control room or marshalling cabinet. Instead of dedicating a wire to every single field device, remote I/O systems digitize analog, discrete, and temperature signals at or near the source, and transmit that data back to the control system over a single communications cable or network connection. This fundamental shift in how signals are moved through a plant has made remote I/O one of the most practical and cost-effective tools available to process engineers and system integrators working in modern industrial environments. The traditional approach to connecting field devices to a control system requires running individual wires or twisted pairs from each instrument back to a central location. In large facilities or installations where process equipment is spread across wide distances, this wiring infrastructure becomes enormously expensive and time-consuming to install and maintain. Remote I/O solves this by consolidating field signals locally and transmitting them digitally over a single cable, fiber optic link, Ethernet backbone, or wireless network. The result is a dramatic reduction in field wiring costs, faster installation, and a system that is far easier to expand and maintain over time. Beyond the initial cost savings, remote I/O also reduces the burden on the control system itself, freeing up processing capacity and I/O card slots for higher priority functions. Remote I/O is particularly valuable in a few common scenarios. When a plant needs to add new measurement or control points, but has run out of spare field wiring, a single twisted pair freed from an existing transmitter can serve as a communications cable, carrying a dozen or more new I/O points back to the control system. When an older DCS or PLC has run out of available analog or temperature input cards, remote I/O can add new points through a digital communications port without requiring new hardware in the control room. Remote I/O is also the right choice when signals are in hazardous areas, when data acquisition points need to be sent directly to a plant historian without passing through an overburdened DCS, or when the cost of running new wire to a remote location cannot be justified. In many plants, thermocouple temperature measurements are brought back to the control system over long runs of thermocouple extension wire. Over time, that wire corrodes, and when it does, it introduces significant measurement errors that are notoriously difficult to track down. At that point, you have a choice. Replace the extension wire in kind and accept that the same corrosion cycle will happen again, or use remote I/O to solve the problem permanently. Since many remote I/O systems are suitable for hazardous area environments and can withstand ambient temperatures of up to 85 degrees Celsius, you can digitize each temperature signal right at the source. From there, the data travels back to the control system or historian over standard copper wire or fiber, using protocols like Modbus RTU, Modbus TCP, or HART. Digital signals over copper don't degrade the way thermocouple extension wire does, so the measurement errors caused by long wire runs are eliminated entirely. Short runs of thermocouple extension wire still connect each sensor to the remote I/O, and those short runs will eventually need to be replaced as well. But replacing a short run is far less costly and time-consuming than replacing a long one. And because the runs are short, you may find it worthwhile to use higher quality thermocouple wire, or better yet, replace thermocouples with 4-wire RTDs, where the temperature range permits. RTDs deliver significantly better accuracy, both at installation and over the life of the system. Beyond eliminating extension wire, remote I/O brings a number of additional benefits. Each remote I/O unit handles the full measurement cycle, digitizing the signal, running diagnostics, performing linearization, and delivering a 32-bit float to the host. The host no longer needs to perform any of that work itself, which dramatically reduces the processing burden on your DCS or PLC and frees up those analog input cards for other uses. Thermocouple extension wire tends to act as an antenna for ambient electrical noise. The millivolt level thermocouple signal is especially vulnerable, and eliminating that wire removes the noise pickup along with it. And because remote I/O is easily expandable, any additional measurement points you add in the future have no effect on your wiring back to the host. One of the strengths of remote I/O is the flexibility it offers in how data is transmitted back to the control system. The most widely used protocol in industrial remote I/O applications is Modbus RTU, a serial communications standard that is supported by virtually every major control system platform. For plants with an Ethernet infrastructure in place, Modbus TCP brings that same simplicity over a standard network connection. OPC is another common option, particularly for sending processed data to historians, SCADA systems, and other software platforms. For facilities using HART-enabled transmitters, HART to Ethernet gateways can pull multiple HART devices and deliver process variables and diagnostic data directly over an Ethernet backbone. Beyond protocols, the physical layer options are equally flexible. Remote I/O can run over twisted pair, Ethernet, fiber optic cable, spread spectrum radios, cellular modems, microwave systems, and even satellite links, making it a viable solution regardless of the distance or infrastructure involved. For applications where digital protocols like Modbus are not practical or desirable, remote I/O can also operate in a peer-to-peer mode. In this configuration, analog and discrete signals are digitized at the field end for transmission over the communications link, but then converted back to their original analog and discrete forms at the receiving end. The control system sees standard 4 to 20 milliamp or discrete signals with no awareness that the signal was ever digitized and transmitted remotely. These peer-to-peer networks can also support bidirectional communication, allowing signals to be transmitted not only from the field to the host system, but from the host system back to the field as well. This approach delivers all the wiring cost benefits of remote I/O without requiring any knowledge of digital protocols or changes to the existing control system configuration, making it an ideal solution for facilities that want to modernize their infrastructure gradually. Remote I/O is especially valuable in hazardous plant areas, where running large amounts of field wiring to a safe area marshalling cabinet is both costly and complex. Remote I/O products designed for hazardous locations are available with intrinsically safe and non-incentive approvals for Class 1, Division 1, and Division 2 areas, corresponding to IEC Zone 0, 1, and Zone 2 classifications. By placing approved remote I/O hardware directly in or near the hazardous area, the amount of wiring that needs to cross the safety boundary is dramatically reduced, lowering both installation cost and long-term maintenance complexity. For truly remote locations where running any physical cable is impractical, wireless physical layer options, including spread spectrum radio, cellular, and satellite communication, allow remote I/O to reach virtually anywhere. Remote I/O is used across a wide range of industries, wherever the challenge of moving signals over distance, across hazardous boundaries, or into aging control systems needs to be solved efficiently. In oil and gas, it connects wellhead instrumentation and pipeline monitoring equipment back to control centers across vast distances. In water and wastewater, it links pumping stations and remote treatment facilities to central SCADA systems without the cost of extensive cable runs. Chemical and petrochemical plants rely on remote I/O to safely interface signals from hazardous process areas. Power generation facilities use it to monitor remote temperature points and consolidate signals from distributed equipment across large plant footprints. Data centers and building automation systems benefit from its ability to integrate diverse signal types into a unified monitoring platform. Wherever signals need to travel farther, cross boundaries, or integrate with modern systems, remote I/O provides a reliable and scalable solution. Remote I/O is one of the most versatile and cost-effective tools available for extending and modernizing industrial control systems. By digitizing field signals at the source and transmitting them over a single communications link, it eliminates the need for costly field wiring, expands aging control systems without major hardware investment, and connects signals from hazardous or remote locations that would otherwise be impractical to wire. With support for a wide range of communication protocols and physical layer options, and the ability to operate in protocol-free peer-to-peer mode, remote I/O adapts to virtually any application or infrastructure. Whether you are adding new points to an existing system, offloading an overburdened DCS, or connecting a remote facility over fiber or wireless, Remote I/O delivers a reliable, scalable, and cost-effective path forward.